So Actuary dude over here looking at another exam question. So the value of assets held by an investment fund on the 1st of Jan 2011 is 2.3 mil. Then at the end of April we're looking at it's ending up at 2.9 mil. And the next day we end up receiving an inflow of 1.5 mil. And then at the end of the year we end up with 4.2. So it wants us to find out the annual effective time weighted rate of return for 2011. So in order to find that, I've already decided to draw the timeline to save a bit of time here. So 2.3 ends up becoming 2.9. And then we can multiply that by, when we got 2.9 plus 1.5 is going to turn into 4.2. So in fact it's going to go down. It goes up there pretty well and then goes down there. And that's going to be equal to just 1 year, so 1 plus I. Some interest right there. And then we'll just find out what I is equal to using Excel. So let's just drag that one across and say, alright, first bit 2.9 divided by 2.3. Now I'm multiplying that by 4.2 divided by 2.9 plus 1.5. That gives us this, and this is 1 plus I, so we just minus 1 from there, which is 0.2036, so 20.36%. Okay, 20.36% per annum. There we go. And let's look at the next bit over here. Double I. So calculate to the nearest 0.1% the annual effective money weighted rate of return for that year. So all we're doing in this case is saying 2.3 times 1 plus I, and then we get our 1.5, and that's going to increase with the same rate of interest, but instead it's going over, so this is the full month of May and the full month of June, and then there's another half a year to that, so it's actually 8 months out of the 12 months, which is also 2/3, and that's going to then be equal to 4.2 when it's accumulated. So we'll just solve for that. So if I call this bit over here our 1 plus I, and this bit can be our interest rate, so it's going to be 1 plus whatever our interest rate can be in B2, and then I'll just be making it equal to that equation that I drew. So over here is equal to 2.3 times 1 plus I plus 1.5 times 1 plus I, and that's to the power of 8 on 12. So all that, so that's 3.8 we need. So if we make the interest rate, let's make it the same as the other one, 20%, so let's go 0.2. Then we're looking at 4.4. So we need to find out, we've got to lower the interest rate to make it 4.2. So let's see what happens if we make it 15%. Not quite. If we make it 10%, so still not quite. So let's go 12.5%. 12.5, we're almost there. We've still got to lower it a bit. So, I mean, you really could be sitting in the exam with your calculator with the time that you're bored in there. So 12.3% is just about there. 12.1%, a little bit too low, so you guessed it, 12.2% is what we need I to be, and that's rounded to the nearest 0.1%, which I think is takes a bit much time. So 12.2%. I is equal to 12.2% per annum over here, which is significantly less than this 20% over here. So the last question, explain why the time weighted rate of return is significantly higher than the money weighted rate of return. And the reason for that is the money weighted rate of return is weighted towards when there's a lot of money in here. And the most amount of money is in this time, when this is actually, what is that, 3.9, 4.4, and it's actually going down. So when we've got the most amount of money, we're actually getting our worst returns, our negative returns. And the time we had the least money, we're getting the best returns. So for that reason, this bit over here is dragging down our interest rate. And this bit's having less of an effect. So that's why the time weighted rate of return is much higher. So ask any questions if you want, but otherwise, thanks for watching and have a great day.